Mm. All right, we're rolling, we're rolling. You all, good evening, and thank you so much for joining and tuning in, being part of the Holistic Hedge. You are greatly appreciated. Listen, y'all know I'm always excited to talk about these math things, this critical thinking, the questioning. So we're gonna jump right in, okay? Y'all know I don't like to waste time. We're gonna get down to business, right? Handle some business, have some laughs along the way. Okay, so first, I'm settling myself a bit because y'all, we're just days away from the webinar, right? Our webinar from questions to mastery, promoting critical thinking with AI in math class, right? Just a mixture of all the things that define holistic fluency. And so we're super excited. So as a result, as we're counting down, one of the things that we're going to focus on this evening is a topic that every educator, every parent, every tutor, right, has encountered this, right? Where you've asked a question and maybe you got crickets, where maybe you were trying to facilitate some thinking, helping the problem solving steps, but then you realize the students are struggling to think in a mathematical way, right? In the mathematical way. So, y'all, we're diving in. Now, with that being said, if the students, the young people are super focused on just the calculations and those things, y'all have heard this lyric. I'm also a hip hop girl, right? They say numbers don't lie, but sometimes the students try to make it tell a story. Sometimes the students try to make it lie if we're not careful. So I want you to raise your hand, y'all, drop an emoji if you've ever asked a math question and got total silence, right? The chat should be lighting up right now. If you've ever asked a question, math question, since we're talking about math, but listen, parents, listen, if you teach other content areas, if you've asked a question and you got total silence. Mm-hmm. Indeed. Right, right. So just know that, yeah, yes and yep, I've been there. And so sometimes when we ask that question, knowing that we should have a response, but sometimes we get that head tilt, right? We might get some blank stares. We might just get a pencil tap. And that one kid that raises their hand asks to go to the bathroom. What? What? Am I on TV? No, this is real classroom life, truly. Okay. So here's the thing. Math classrooms, we always say, aren't just about numbers, but they should be about thinking, critical thinking. And so if the students are not thinking, not truly thinking, then something's missing. So what we're going to do this evening, we're talking about the 5 critical warnings about critical thinking in math class. So 5 warning signs, let me rephrase it, about critical thinking in math class if something's missing. So we made a post earlier this week. Y'all bear with me while I share the screen this evening. Okay, let's see. Here we go. Just waiting for it to switch over there. Here we go. Y'all bear with me. Y'all know we're working hard over here. So sometimes my computer gets tired too, right? So let me see. I gotta move a couple of things. So we can run through. I want to make sure y'all have a very clear shot of this. So we put it in present mode. Okay. So our 5 things, y'all. If we have that, you know what? Critical thinking has been missing in your math class. Let's dive into it. Let's talk about all 5 of them. So the reality check is that the students are super excited about their computation, always ready to do their computation. But are they thinking? Can they think? For many students, and y'all chime in, y'all echo, y'all say amen, y'all say yes, right? Send me some flames, some thumbs up. Let me know if you've seen or experienced math instruction become just a game of memorization rather than meaning. If you've seen math instruction become just like a rush to finish rather than a journey to understand. Let me know if you've seen math instruction become just like a script to follow rather than a puzzle to explore. Okay. Yeah, some of the common struggles, one of the things, students relying on formulas without understanding. So we might find that our formula followers, right, they can apply formulas sometimes, but they have no idea how they work and why they work. If we see that students are just plugging in numbers, sometimes they're just, so first of all, the people that create the test items, yes, they're being tricky on purpose. They are. They're being tricky on purpose. And so they're putting some extra numbers, including some extra numbers by design. So if we have students that are just programming themselves and we're allowing them to program themselves as simply formula followers, they are plugging in numbers that they might need. They're plugging in the incorrect numbers because, again, they have no idea the how and the why behind the formulas. Okay, maybe they can plug in the Pythagorean theorem numbers or some numbers to try to solve for the Pythagorean theorem, but have no idea when it would apply in real life. They have no idea, can't explain why that only works with right triangles and not every shape everywhere, right? All right, so that's number one. Number two, speaking of open-ended questions, if we ask them, right, why does the Pythagorean theorem only apply to right triangles? And suddenly everyone's stuck in freeze mode, right? Like we're playing freeze dance, teachers of little people. Y'all, open-ended questions cause panic. So the second a question doesn't have a single correct answer, or which one is it, A, B, C? Yeah, what? Too many of the students freak out. It becomes an uproar in the class. Um, you might ask instead, how many different ways can we solve this problem? And they might respond, what? There's different ways we can solve this. Okay, so imagine making sure that we give space for them to solve all the different ways. And I'm saying all the different ways, but just reflecting on some recent work a couple days ago with a student, a one-to-one tutoring session I was facilitating. And this young lady is working on dividing decimals. And so we are taking it layer by layer, right? There's different things to know about dividing decimals. So one of the things we practice is making sure that she understands different strategies to apply. So in this particular session, we're working on whether or not we would use like the place value strategy, knowing how to multiply the numbers, the decimals, so that it becomes and looks like, keeps the same ratio, but becomes a whole number problem. Slash, we also did a base 10 block representation, so drawing the picture and creating our groups from there. Slash, we also use the number line, right? To also model the division involving these decimals. And y'all, I must say that I was so very proud because the students said, okay, also, Mrs. Jones, I have another idea for another strategy. I said, what are you thinking? Share your thoughts, right? So she said that if she was like, okay, if it's division, even though it's decimals, can we still use repeated subtraction? Because that's how we normally can do division for our whole numbers. I said, then yes, you sure can. And so even though that wasn't necessarily on the list of what we were focusing on, the goal for that day was making sure she understood different strategies, but made connections, and goal met, right? Check and check. So one thing when we're talking, we'll talk about it a little more, just some tips for when students need to explain their reasoning, because sometimes that's different for them. But we're going to talk about how to frame it to help encourage the share. Y'all, number three, math becomes just steps to follow, and it's speed over reasoning. Okay, so speed over reasoning. So they only care about, did I finish first? Right? They're not checking their work. They're not understanding the why behind what we're doing. When students aren't checking their work, well, actually, I've been very it's given me a lot of pause. I'll say that, especially in, I won't say that it's any more known in any grade band. So it's not like elementary knows more than middle, or middle knows more so than high school, or there's no um I guess, no clear forerunner, I'll say, in terms of my more recent direct work with young people, whether or not students know how to check their work. So that's been a thing. I'm excited to say, hey, we just finished this subtraction problem, right? Maybe first, second grade. How do we check this? Do you know how we can check this? What do you mean? I'm like, do you know that you can know before your teacher if you got this correct, right? You should know if you got all of your points before you press submit, before you go up to the teacher's desk, right? Or wherever the turn-in spot is and turn your paper in, you should know first. And if they don't, right, we're talking about questions. Y'all, the questioning becomes even more of a big deal. Like, okay, let me give you some Mrs. Jones hacks. Let me give you some Miss Jones clues. So you just subtract it. And we know about our math operations, how there's some that do and undo each other, right? That they're related. So if I just subtracted, is there an operation that's related, that's connected, that might be helpful to check this? Addition? Yes, addition. Okay, okay. So you're rolling out, right? So if we're going to add, I need you to be super specific for this problem. Add what? Then they think through it. Most of the students figure it out because even if they're in second, third grade, first grade, students have had their previous experience, or this is why this terminology and experience is important with the parts and wholes, or parts and total, because they recognize their total. We subtracted a part and got a part. So usually they can work backwards. They come to that conclusion, they make that connection themselves. But what got them there? The question. Even if it wasn't on their mind to check, they didn't know they could check to see if they got their answer correct or not. But now they do, and they make the connection themselves. Okay. So again, having them just explain their reasoning. Also, another thing about the explaining their reasoning. So sometimes students are like, what? Because that's the one thing I give students a heads up. I'm like, okay, look, before we start, let me tell you that Mrs. Jones is super serious about you sharing your strategies, letting me know how you're thinking, what you're thinking as you solve these different math problems. Tell me what you're thinking while I'm modeling for you. I'm going to share my thinking as I model as well. And for a lot of students, they're like, this is absolutely wild. This is not something, no, this is not normal, right? This is something different. So what ends up happening is my reframe, right? Where the SEL enters the math class, we reframe it. So a lot of the students, we're very aware of YouTube, right? YouTube University, whether it's they're really trying to learn something, like how to do something, or they're on YouTube for entertainment. They've seen and consumed so much content. So imagine this reframe. Okay, so I know that that's different for you, what I'm asking you to do, sharing your reasoning, but have you ever seen a video like on YouTube or something, and even if it's like a gamer or someone's just kind of teaching us how to do something, they say, okay, now I'm going to go into the room, and my plan is to make sure I get and they're like, oh, yeah, yeah, I've seen those kind of videos. Okay, well, that's what I need you to do while you're solving the problem. I need the play-by-play, okay? Oh, okay. Whoop. Yes. Yes, really that simple, right? Really that simple. The refrain, and then they just bought in. And again, we're rolling. Now we can really do some things. Also, because telling them that the more you talk, I said this is rare, but the more you talk, the more you share what's going on. If we have to make an adjustment, I know exactly where to help you because you were super thorough in your explaining. I said, remember, I'm not even saying if it's correct or incorrect. I just need you to tell me what's going on in your head and why you think so. That's it. That's what I need you to do so I can do what I need to do. All right. Number 4, you all, math becomes an isolated set of rules that don't connect to real life or across concepts. So for some, it just becomes just a set of rules to follow. So if students only learn math in that way as a set of steps, they're not thinking, it's more like a checklist. Y'all, they aren't recognizing the patterns and making connections. In general, When I'm talking about math, regardless of the grade level, and I know it's going to be one of those concepts where, maybe it was taught, maybe I learned it with rules. I've heard a lot of teachers teach it with rules, but we talk about an exploration and discovery, right? That's some of the phrasing that I'll use. And then there's little miniature tasks designed so that the students discover the rule, discover the pattern themselves, because how much more, and especially all adults on here, how much more do we retain information? Do we remember so we can apply it when we come up with it ourselves? When we have some experience to draw back on, not just what did Mrs. Jones say happens? What do we multiply a positive times a net? Is it a positive? Is it a negative? But if they have, again, they've had a specific set of tasks to help them make that connection. They're exploring. We're asking the questions again that are connected to the task that get them where they need to be, right? It helps them go from here, right? This is where you are. This is the information I need you to know. Questions get us there, you all. Now, this last one, I cannot stress enough. You all know I've spoken about it quite a lot. You all know how I feel about error analysis, and I really don't understand when people act like mistakes are the plague, right? So number 5, mistakes are avoided instead of analyzed. Whew, when I talk about the depth of information, not just information, but so wisdom and insight, the reflection that comes from analyzing the mistakes, right? Instead of, because, and so that's part of the talk as well with young people, like, okay, we made a mistake. Did the ground open up? No. You still here? I'm still here. Are you still here? Yeah. Okay. And I talked about on the previous live. Maybe you make a mistake. So are they showing us ourselves? Are they holding up a mirror to us where we're so um, conscious, self-conscious that we're a little bit tense about making a mistake? Well, I mean, what same thing that I ask the young people. What's the worst that could happen? Right? We're in here learning and solving math problems. If Ms. Jones makes a mistake, please catch it. Right? That's y'all, we're in here working and learning together. What is the issue with making a mistake, right? When students erase their work, the second they feel like, oh, that's not what she said the answer was, instead of going back, then we just lost a learning tool. Because maybe they actually understood the concept, but it was a slight calculation thing. Maybe like we talked about those integers, they're positive times that negative. Maybe we messed that part up. So we need to do a discovery activity on that. Maybe, no, I'm just not understanding how to solve this particular question. I'm really not sure. Conceptual, then okay, that requires more work, more experiences, exposures, and conversations, and that's fine. That's fine. But now you know that versus just, let me kind of just try everything all over again because I'm not sure exactly what parts they're not getting. Boo his boo. We're not doing that. We're not doing that. Y'all, please, in the comments, in the chat, drop a number. Which of these signs have you seen the most? Have you heard about the most, right? In class, maybe at your house. Relying on formulas, number 1. Number 2, if it's an open-ended question, because I do see that on homework and some assignments sometimes, and the students are like, I just want to plug in some numbers that's up, right? Is it number 3? We're speeding through it. I give kids speeding tickets. Like, yo, no, I don't have a medal for you, but I can give you a speeding ticket if you're going too quickly. Okay? Is it number 4? Again, that is just like a checklist, just some rules to follow, and they do not see the application in real life. Right? Is it that? Or is it we're just erasing versus reflecting on their mistake? Literally with my son at home. When we're checking in, he normally takes tests at the end of the week. So I'm like, oh, how'd your test go? Pretty good, Mom. I'm like, how do you feel about it? I felt pretty good. I'm like, asking for his evidence too. So how do you know you did well? This, and this, if they haven't checked it yet. If they did check it, And he's learned that I'm going to ask him about the questions that he missed. I'm like, okay. I'm like, all right, bud, that is a great grade, a great job. You know, your hard work showed. But what questions did you miss? And he's able to tell me and tell me why at this point, right? It's March. So we've been working on it, right? Because you know, the third grade, y'all know how third grade is. We're leveling up. So he's able to tell me what he missed and why. So maybe he's still connecting it to some type of strategy because for his time tests, like when they're doing the multiplication facts or division facts, he's like, well, Mom, I got stuck on one and I know I don't want to use all my time on that one. So I skipped it, filled in the other ones, but then I ran out of time before I got to come back. Okay, cool. Right? Another one, he maybe a different test. He's like, Mom, I was figuring it out. I didn't know it right away, but I was in the middle of solving, and maybe he ran out of time. But he knew what to do to figure it out. Yeah, those are big deals, especially being able to explain maybe the strategy you were in the midst of your mistake. Right? Okay. Next, I'm gonna stop sharing this for a moment because we're talking about now the solution. So I've said it a million times on this live already so far, but questioning. We ask questions all day. So I'm not just saying ask some more questions, not that. The questions need to be richer. Richer questioning is key. So way beyond, so what answer did you get? What's 7 times 6? No, no, no. If you know what 7 times 3 is, how can that help you figure out 7 times 6? What would you do? Maybe instead of solve for X, can you find an equation that would give us the same solution, but in a different way? What? Okay. So we're talking about the real life application. We're talking about multiple strategies. We're talking about open-ended questions. You want all of this, all of these things. Then taking advantage. Another aspect of the solution, taking advantage of discussion time. If if you happen to be around when I was on a tutoring session with the student, you would think we were just talking. We are, but we're talking about math, right? Because it's such a smooth conversation that's building on what they know and what I need them to know, right? So full classroom life. A lot of people use this, the turn and talks, right? Like they do at church. Turn and tell your neighbor, like that. So the turn and talk, classroom life, we call it think, pair, share, where you think about it first, you turn and tell your partner, y'all talk about it, right? Because maybe someone has an adjustment to make, slash, it gets you to explain to your peer how you got to your answer before we all share out and have a full conversation. I cannot stress enough the importance of talking about math, reinforcing that vocabulary, and just making these connections so they see and understand that it's here. It's not going anywhere. It's a part of life, right? So even in the midst of that, asking about what mistakes, again, the error analysis, what mistakes might someone make on this problem? Yeah, that goes back to, like I said, those streaming conversations, right? The closure. Okay, we've been studying dividing decimals. If you had to give your top 3 tips, you're doing content, some seventh grade math students need some tips. What would you say? Right? And they might include some of the misconceptions, common mistakes, and things to be careful about, slash general examples for how to solve. Yo, I've had some really, really good. You just have to give it to them, right? You have to give them the space. I've had some really, really good reflections. They get detailed. They use their vocabulary. If they need some help, you're not helping with the vocabulary. I don't want that to hold them up from doing their overview, right? Their reflection for what they learned. Another layer of the solution, intentional use of AI, intentional support, not replacing thinking. If literally part of our pillars, what we're talking about, what we work on is developing this critical thinking in our young people in alpha generation and the little beta babies coming in just a moment. They'll be school aged, right? We're not talking about replacing thinking. We need deeper thinkers. So we need to be using AI as a tool. Yes, it can generate questions. What else can it do? It can provide scaffolding, right? So scaffolding is, for example, we need students to understand proportions, right? Proportions, and they're like, I haven't done this. I don't know what that is. You have done proportions. We used to call it equivalent fractions in earlier middle school and in elementary. So proportion, we just call it something a little bit different now that you're a little bit older, but that's it. Or even just asking questions along the way so that they get there, right? Besides giving them the content connections, scaffolding is laying out, again, questions. You're here. Right now, you feel like 1/3 is less than 1/6. I need you to understand that actually 1/3 is greater than 1/6. And we're filling in the pieces, we're filling in the gaps with the questions for how to get there. Okay. So besides even generating some scaffolding questions along the way, we talked about the adaptive AI, right? How it can adjust. Some of the platforms that adjust automatically where they say, oh, this is the thing, right? AI can recognize it too. Say, okay, well, this student needs more practice for, like we just talked about, the comparing fractions, the greater than, less than, equal to. They need some more of that. So that's the questions they get. So it's more personalized, and again, it can adjust based on what they need. So a common practice is for people to think about AI as just providing answers, just generating answers, but it should be, again, a thinking partner. We keep saying that phrase. Think of it as a thinking partner. The last step of the solution is real world application. Again, I know we talk about this all the time, but how often is that brought in with the questioning into the classroom? So math as a life skill. One of my favorite sessions recently, this young lady, she's in middle school, she was working on unit rate. You know, unit rate is finding out how much for one, basically. So we were, we've done like some of the, I'll say, some of the lesson questions like, oh, it's this much to register for a bicycle race. The team has this many people. This is how much they paid as a team. So how much does it cost for one person? Something like that. So we went through those. Not necessarily relatable for her, but listen, we have a solution for that. So we can do both. We make sure they get the exposure and experience, and then we bring it back to something very relatable. It was around Valentine's Day. I said, hey, let's pretend that you're planning a party for you and a few friends. She said, yes. I said, okay, let's go shopping. So we pulled up like the advertisement section for her grocery store, her neighborhood grocery store, put in her zip code. They pulled up the one, oh, that's the one by my house. Cool. Click on that, open that. So I was like, okay, I told her we're going to get 3 items. I think she got cookies, cake, and some punch, right? So for each item, she had to get at least 2 so we could compare because we were looking for the better deal. So, we're going through, and at one point, of course, right, these natural reflections, these natural connections. She said, Miss Jones, she said, this bag of cookies had more, and it seemed like the price was going to be less or it was going to be a better buy. She said, but it was still more expensive per cookie for each cookie in the bigger bag than it was the smaller bag. I said, now, hey, that happens a lot. I said, that is literally a life skill. I said, that is something that adults are doing, I said, or should be doing, right? As we're working on our budget and just deciding how we're going to spend our money. I said, when we think about some of these warehouses like Costco, things like that, yeah, just because it comes in a bigger quantity does not necessarily mean it's the better buy than like your HEB local grocery store, right? So all of that to say, do your due diligence. And that's, she learned that herself. And imagine as a middle schooler, she said, okay. I said, but you know what? I said, you can literally do this walking around the store. I said, next time you're in the store, you can do this yourself and compare. Because she locked in on what operations she needed. We're dividing. She understand that we're finding out how much for one, whether there was one cookie, one cupcake, whether it was ounces when we did the juice, right? So we got some real life lesson in that day, and it was really good. So just some of the things. It can be anything. Think about the sales, or we have different sales coming up, Memorial Day sales and Black Friday sales, all of that. Make it real as much as possible. So thinking back again to your own math experience, what's one way that your teachers could have helped you think more deeply about math? We just went through a few. What's one way? Or maybe some people will say like more hands-on, right? Just more time connecting. Okay, so connecting between concepts. And one thing that's different, when we talked about the think, pair, share, or turn and talk, turn to your neighbor, right? That part again. That this generation, these past couple of generations have benefited from collaborative learning more than previous generations, right? If you think about even the arrangement of the desk, if there's desks, right? Some classrooms don't have desks, they have tables. Yeah, because they're encouraging the collaborative learning, the exchange of ideas, the exchange of information, learning from each other. Yeah, so those are just some of the things, right? Some of the things that people are like, you know what? I would have appreciated if that was different. So we talked about the things to look out for, to be careful about. We talked about some solutions. Okay, so what's next? Glad you asked. You all make sure that you register for our webinar, right? It's coming up on Sunday, March 16th. So same bat time, same bat place, 6 o'clock Central Time. We're focusing on being able to ask better math questions, right? That really spark that deep thinking. We're focusing on AI strategies. We've talked about AI a lot, but we're going to get super specific about some strategies and prompts to enhance, not replace math instruction. Also, the hands-on walkthrough of some practical questions, right? Because maybe we need to kind of practice and see where we are with our level of questioning, right? Sometimes we're asking a lot of questions all day, but if it's a lot of what, when, that's a recall, and that's relatively low on the thinking spectrum. It's pretty low, honestly, on the thinking spectrum. So we're going to talk about the different levels, right? People used to talk about Bloom's taxonomy all the time. I rarely hear about it anymore, and I don't know if everyone kind of got burnt out, but there is definitely a lot of value in reflecting on that, reflecting on where most of your questions are, and making sure you're intentionally developing questions at the different levels. Because again, if we are doing the what and when, but then assessments are generally how and why, woo, that's a gap. That's a big gap, and that's a big difference. Okay. So again, looking forward to seeing you all at the webinar. Make sure that you share the information, right? If there's a parent, an educator in your life, educators, yo, share this information. Tell them, listen, this is not something that they want to miss. We're going to have some resources and templates for you as well, and a sneak peek. We talked about the AI-powered assessment toolkit, which is super, super specific about using AI in math class, different assessment tasks and things to do. It gets down to the nitty gritty because again, we're trying to make sure we take all of the guesswork out, the hard work. So you know what, kind of being a little bit funny, we don't need you to critically think about that one. We did that for y'all for this, right? Y'all are making sure the young people are getting their critical thinking on, so we can hook you up, we can help you out by making sure we took a lot of that guesswork out of this process for you, okay? So make sure you stay tuned and look forward because we're going to have again some little sneak peeks and resources coming out soon. So thank you again for joining you all. If you are super serious about strengthening critical thinking in math, if you are super serious about leveling up in your questioning game, if you're super serious, super curious about how AI can impact the math class, then I'll see you Sunday, okay? Thank y'all so much for tuning in. I'll see you later. Bye-bye. Good night.